Hello guys, welcome to DataFuse Analytics, where the concepts are simplified and explained intuitively. In this particular video, I will be going to tell you all how to make your transformer models efficient and scalable on CPU so that they can be deployed in production environment. I have selected CPU because CPU servers are cheaper than GPU servers. Let's start this interesting session with a story. Let's consider a scenario where you are happy because you have deployed a transformer model which detects whether a movie review is positive or negative. These movie reviews tells users about the overall opinion about a particular movie as well as few strong and weak points about a particular movie. This model which you developed is highly accurate, and now your superiors have told you to deploy the model to production. You are happy and you deployed that model to production and you went home. But wait, the next day, as soon as you come into office, you are bombarded with messages which highlights few important issues about the model. The first issue is the model's response time is very slow and is taking a long time to generate predictions or to output movie sentiments. The second issue is the hard disk and memory requirement is huge for the model. It means that the model is utilizing huge or large primary and secondary memory on server. To make it more precise, in Hindi language we call this as code fat gaya or system fat gaya. Now you take your own sweet time to think about the problem and decide to make the model more efficient, scalable and actual production ready. You come to know a few important things. The first important thing is, in many situations, end users or most of the stakeholders of that particular project can compromise with a slight drop in accuracy or whatever metric which you choose to evaluate your model. The second important thing which you realized is, your state-of-the-art model is literally useless if it is too slow or it is very large to meet the business requirements of your application. At this stage, you might think of training a new model which is smaller and lighter than the original version of the model. But remember that this reduction in model's capacity is often accompanied by a degradation in performance in terms of model's accuracy. Now, in such situation, what to do? Don't worry guys. There is a solution where you can use the same version 1 model which you deployed in production. In this video, I will be discussing few special techniques which are used to speed up the predictions and reduce the memory footprint of your transformer models. These techniques or these special techniques are as follows. The first technique that we will be learning and implementing is knowledge distillation. The second technique is quantization. The third technique is graph optimization with ONNX and ORT. The full form of ONNX is Open Neural Network Exchange and the full form of ORT is ONNX Runtime. The final technique that we will be learning is weight pruning. In this particular session, we will be comparing different versions of our model on 3 performance benchmarks, which are model's performance. It tells us how our model performs on test data. The second performance benchmark is latency. It means how fast our model generates predictions. And the third performance benchmark is memory. How much memory and hard disk space our model takes up. So enough of this theory now, and let's jump into implementation in Python.